morning everyone. We at Science Innovation Club try to find a new idea, method or device nominately or the introduction of something new. Innovation is the practical implementation of ideas that result in the introduction of new goods. Science innovation underpins improvement in human welfare through technology, which it develops for health, food production, engineering and communication. Science is also important in solving problems created by human activities such as environment degradation and climate change. This year in Science Innovation Club, we worked on different themes like eco-friendly innovation and ideas, artificial intelligence and robotics, DNA technology and fun with experiments. We also brainstormed on few topics like science and technology in nation building, scientific innovation of 2021, innovators and their innovations. Now, we present some of the activities we have done in this club.
Hello everyone, my name is Idan from grade 6A. Today I am going to be performing the rising water experiment. For this, you will need matchsticks, a glass of colored water and a coin and a plate. And so what you are going to do first, you are going to pour the water into the plate. Then you are going to bring out 2 matches. Now you break one match in half. Now once you have done this, you take the coin and you submerge the broken half into the water and you put the coin on top for support. Now you are going to light the other match with the other match, and once you do this, you are going to invert the glass on top of this. And once we do this, the flame slowly goes out and the water starts rising into the glass. This is because fire needs oxygen for combustion. When the glass is inverted onto the flame, the oxygen supply is used up, and to take up this space, the water rises into the glass. Thank you.
Hi everyone, my name is Nikhil and today I am going to be telling you about the magnetic field of a magnet. So, what is magnetic field? The space around a magnet in which if small magnetic substances such as iron fillings are placed, they get attracted towards the magnet. In fact, the earth itself acts as a huge magnet but has no magnet inside it. Now that we learned what is a magnetic field, I am going to be showing you an experiment to determine the magnetic field of a magnet. So for this experiment, you need a white paper, a magnet. You can use any type of magnet, but I suggest you can use the bar magnet, and some iron fillings. So you have to keep the magnet under the white paper in the middle. And then you have to take the iron filling and sprinkle it all over the paper. After sprinkling for a bit, you can see some of the iron fillings start aligning with the magnetic field of the magnet. You can just put some more. And then you can just tap a bit. Now, as you can see, all the iron fillings have aligned to the magnetic field of the magnet. Thank you.
Hello everyone, my name is Kavya Thakre from 6C and today I'm going to do a simple experiment called avoiding pepper. For this experiment you'll need liquid soap, water and some pepper. Let's see how this experiment works. So I have my water, my pepper and my soap over here. So first I'm going to sprinkle pepper in the water. Alright, now that we have sprinkled the pepper, we're going to take a small amount of soap on the tip of our finger. Now I've got soap on my finger and now I'm going to touch the water. You can see that the pepper runs away from the finger. Well, it's not the pepper that runs away, but in fact, it's the water underneath the pepper. The soap on the tip of your fingers reduces the surface tension of the water underneath it. This means that the pepper has to stay on top of the water with highest surface tension. And so, it gets as far away as from your finger as possible. Thank you.
And I am from class 6A. Today I will be showing you my electromagnet. An electromagnet is a current carrying coil with a core in it. For this experiment, I have taken an iron screw, an insulated wire and a battery. Usually people use an iron bar, but as I don't have an iron bar, I am using an iron screw. And you can use a copper wire, but I don't have one, so I am using an insulated wire. Then I attach the ends of the wire to the top and bottom of this battery. Now I can attract other magnetic materials with it, like this iron pin. Like this. This theory that electricity and magnetism are connected to each other was founded by Hans Christian Ørsted. Thank you.
Hello everyone, my name is Sainathan and today I am going to be talking about my power generation by windmill project. So now, as you can see here, we have a fan that doubles as a windmill, the powerhouse that gives most of the power, and a small shed that I have built out of cardboard. Now let's turn off the lights. Now, as you can see here, I have turned off the lights to ensure maximum vision of the lights. Now, let me show the dial on the fan to simulate wind. Let's turn on the dial. And as you can see here, the faster the dial blows, the faster the fan moves, so that the light turns green. This is how the wind turbine produces electricity. So everyone, that was my wind generation by windmills project. I hope you liked it. Thank you.
Hello, today I will be making edible spoons. You have to mix the flour based on what you are going to eat it with. So I used flour, ajwain, garam masala and turmeric. So let's get started with it. Mix it in a really soft consistency like this and roll it thick. Flatten it neatly and put a spoon on top like this. Now, cut it in the shape of the spoon but a little bit thicker. And now, remove the spoon out of the excess. Now, grease a spoon with oil and put our dough spoon on top of that spoon. You can see that I have made a few like this. And I have also put it on a tray. So now, put it in the oven and make a few holes in it before you put it in the oven. After some time, as you can see, after some time in the oven, the spoons are turning brown. This is how it looks. So I have removed them from their spoons and now they are hardened. As you can see, they are rigid and hard. So you can just eat with it and then eat it up. The front and back are cooked well and as you can see, there are holes in it. So this is how the end piece looks. This is our end product. Thank you.
Hello everyone, my name is Shivat Karaut and today I will be doing the acid indicator test. First, I will take my turmeric paste, which I have already made. And in the bowl that I'm showing, I will put detergent in it later. And in this one, I will put vinegar later. Now, as I've already made my turmeric paste, I just have to put it on the paper or smear it on the paper. Now, as you can see, I have covered the whole page in turmeric paste. Now what I will do is that I'll take the vinegar and pour it into a bowl. Then I'll take my paintbrush and draw some patterns on the turmeric paste page. And as you can see over here, it makes a yellow pattern. Now I will take my detergent and put it in another bowl. Now since it's only dry, I will put some water in it too. And now I will mix it. You can see that it's now a detergent and water mixture. Now I will take my paintbrush and draw some patterns on the page.
As you can see from afar over here, you can see that some red spots coming in. I will show it closer in a second. Now, as you can see over here, there is red spots on the paper. Now, why does turmeric turn red with detergent? So when you put a drop of detergent solution, when you put a drop of detergent solution on the strip of turmeric paper, the turmeric paper turns red because the detergent is acidic. Turmeric is also known as an indicator. The indicators change their colors when a solution containing acidic or a basic substance is added.
Yes. Very good.
Thank you.
So my experiment will be on ocean acidification, and to demonstrate that I made a simple experiment. So in this wooden plate I have powdered food coloring, and I'm going to add some water to it first. And as you can see, it's turned a bit liquid. Now I'm going to mix everything inside it. Okay. So I've mixed everything, and now I'm going to add some Eno to this. And it will start to bubble up a bit. And can you see it's bubbling up? Okay. Now these bubbles are formed due to carbon dioxide. But in the Eno contains sodium bicarbonate, which is baking soda, and it also contains citric acid. And when this mixes with the water in the liquid food coloring, it creates carbon dioxide and water as a byproduct. And when carbon dioxide and water, they both react together. And when carbon dioxide and water react, they create something known as carbonic acid, which is what we see over here in these bubbles. Similarly, when humans, we burn fossil fuels, we release carbon dioxide into the air. And when that reacts with the seawater, it also creates carbonic acid. And that carbonic acid is slowly turning our oceans into acid. Thank you.
Good afternoon, everyone. Today I am going to do a bubble experiment. For this experiment, you need one plate, a container, and a straw. In the container, fill water and some hand soap and make it a solution. Now I'm going to blow a bubble on this plate with the straw. Now I'm going to blow another bubble in this bubble. As you can see, here I have blown a bubble, and inside this bubble I put the straw and blew another bubble. Now I'll tell you how this happens. Washing up liquid with water forms a solution. When you blow a bubble, the air is trapped by a thin film of your bubble mixture. This film is made of a layer of water sandwiched between two layers of soap. A bubble pops if the soapy outer skin is broken. This can happen as the water in the bubble evaporates, or if the bubble touches something dry or oily. It can also happen when the bubble becomes too big
and there isn't any more soap to create the sandwich layer. If your bubbles last a really long time, you might see the color shift as the water drains around the sides of the bubble back onto the flat surface. Eventually, the bubble gets so thin you can barely see it right before it pops by drying out. Wetting the straw by dipping it in the bubble solution allows it to slide into the bubble without popping. Thank you.
Good morning everyone. My name is Nikhil and today I am going to show you a simple experiment using only two things, Fevicol and sugar. Preferably powder salt. So let's start with it. So first uh, put some Fevicol in your hand. Just do like this. Okay, so as you can see, I have put Fevicol in my hand. So generally, it would harden and you would get a tough time taking it out. But if you put salt around it, like just like this, just spread it around the Fevicol as I'm showing you here, and just do like this for 1 or 2 minutes. Just keep on doing like this.
Nikhil, the other one is salt, right?
Yes, it's table salt powder, or you can use powder salt or table salt. So if you do this for 1 or 2 minutes, you can see that the Fevicol comes out, and so the Fevicol comes out. You can see that my hand is clear and nothing. There's no like hardened Fevicol or nothing is there. This happens because when salt absorbs the thickness of the Fevicol, and the thickness is also absorbed, so the thickness goes away and you can take it out. So you can see this, it's the Fevicol is stuck with the salt, and the salt is like becoming like sticky, and your hand is safe from all the Fevicol. Thank you.
Hello everyone, I am Satvika Acharya from grade 6C. Today I will do the air pressure experiment. For that, we need a glass of water and a chart paper or cardboard. Here I will put the cardboard on the glass of water and I will press it. I need to hold it very tightly for a few seconds. Then I will just turn it around. Then I will slowly remove my hand. We see that the chart paper doesn't fall because underneath the chart paper has more air pressure than the air pressure in the glass of water. Thank you.